Okay, folks, so we need to talk about how to process data from my gas chromatography system. So this is after my sample has already ran through the machine and I get my big fancy chromatogram that comes out in the very end. So I see a flat line and then a peak comes up and then back down and then another one and then another one, and let's say this is just a three-component system. All right, so I'm going to label these as peak A and B and C. Okay, so each one of those peaks represents a different component of my sample that I have injected. And when I print off the report, down here at the very bottom, it's going to give me a table. All right, now the table first is going to include something that we call retention time, or T sub R. So this is retention time. And the retention time is how long it took for the sample to go into the machine and for that component to come off. And the retention time is typically in minutes. So my A peak will have a retention time of maybe 2.08 minutes. And I'll put that unit up here at the top. We'll make a table. And then the B component is another piece of my sample that came through. And that piece also has a retention time, T sub R. And let's say that retention time is 4.56 minutes. And then the C component will also have a retention time. And that C component, let's say, will have 8.13 minutes. So this gives you an idea of how long it took that component to come off of the machine and to be seen by the detector. All right. Another piece of this table down here below, and you've got to be careful, because sometimes it gives you all kinds of info down here at the very bottom. We don't care about any of that other information. Whatever is listed down there, who cares about it? We just need to focus on area. That's it. Not area percent, not height percent, but full-blown, straight-out area. That's all that we need. And there's going to be a number down there at the very bottom. So what the detector does is it says, okay, here we have the A peak, and this is a component. And the machine says, well, if nothing came off, my baseline would be about right here. But something came off at this moment, and we have to calculate how much. So the instrument software will look at this peak, and it will calculate the area that's underneath that curve. And whatever area is there, that's what goes here. So let's say that this is 1,273. It could be a really big number. It could be a really small number. Doesn't matter. We're just using it as an example. All right, well then it will go to peak B, and it will say, look, here we see a peak. There it is. We'll calculate the area up underneath it. That area is going to be smaller because the peak is smaller, right? So let's say that this one's 127. And then it's going to do the same thing for the C peak. There's a baseline here, and it calculates how much space is up underneath this peak. And then it says, all right, well, we've calculated 874. Looks like I like to use sevens. So these areas are very important. And we need to use those areas in order to solve for my concentrations and my samples that I begin to run and analyze. But these are the only two pieces of information that you need from the chromatogram. This is it. Retention time and area. The retention time tells me how long it took to come off, and the area will tell me how much space is up underneath that curve. All right, so in the next video, what we'll do is that we'll talk about the standard preparation and how to treat the standards, because you have to know how to do that before you start using these areas for your sample, right? So this is a sample chromatogram, and we've got to figure out what to do with these numbers. Before we do that, though, we have to talk about the purpose of a standard.